Welcome to our training session focusing on refrigerants and oils. Today's presenter is Don Gillis. Please note that you will be able to access the audio of today's presentation through your computer speakers. Following today's presentation, a recording will be available to you on our contractor resources and HVACR training pages on our website at climate.emerson.com in a few days. In addition, we'll be providing you with a certificate of course completion following the event via email in a few days. Our session will now begin. Don?
Thank you, Kara. Thank you, everyone, for joining us today. We appreciate it. It's been a lot of fun presenting these programs for you. Hope you're enjoying them. As Kara said, this will all be put up for you. She'll tell you how to get to all these later. They are being archived. Today we're going to talk about refrigerants and oils. We're going to talk about refrigerants, some of the new refrigerants that are coming down the pipe. We're not going to touch on everything, but just a little bit. And we'll scope on oils and what that looks like in our applications. And then I threw in a couple slides. I want to talk just a little bit about glide with refrigerants, especially the blends that we use and those kind of things. So let's get moving forward. So again, I'm Don Gillis. I work in educational services. I work under Ben Weiser. I've been with the company just under 3 years in July. I am a licensed journeyman, and I've worked in the field a handful of years, almost 28 now. So I threw this in here too, only because we got a lot of good feedback on our apps. Here's a picture of an app I think Kara or Amanda put together for us. The AE Bulletins obviously on the left-hand side, your Copeland Mobile in the middle, and then your Emerson PT Pro. The only one that's not here that we're going to be talking more about probably next week that Dustin Tillery mentioned was the HVAC Fault Finder. And on that app, you're looking for a magnifying glass and kind of a stoplight look, red, yellow, green type thing there. Okay, so Copeland Mobile is going to be everything. A lot of the apps are moving into this. AE is already in it. Okay, you'll be able to look up lots of things here in the AE Bulletins, and I'll more than likely touch on this one today when we talk about our 93-11. Which is our oil and our refrigerants, what we approve of and what application we approve them in. So I just wanted to put that out to you there. Okay, talking about refrigerant replacement oils a little bit, some things that are coming down the pipe. A little bit on topic here, just a glimpse at some of the natural refrigerants. I'm not going to spend a lot of time on this, but just to make you aware of it, this is a nice picture to look at in the reference of CO2 refrigerant. So CO2 refrigerant, because of the new restrictions or the things that are coming down the line with the EPA, it looks like one of the only options possibly might be CO2 in some applications, specifically supermarkets, okay? Because the larger the system, the less potential of, or the more potential of leaks. We have to have a lower global warming potential. So this is just showing you what 1 ton of CO2 might look like compared to, look over here, 8 ounces of 404A is the same equivalent of that 1 ton, okay? This is just a graph. I'm going to go through this fairly quick. Again, I just slipped these in last night, just kind of build you up to what we're going to work with, some of the newer refrigerants. The real reason I put this in here is because of the pink colored boxes, the A2Ls, which is going to become very, very popular in the near future. So at the bottom, you'll notice the global warming potential from 0 to 2000. Some of you I spoke with the other day, I've done a couple presentations on CO2. So CO2 is the starting point for all global warming potential numbers. There's less global warming potential in some refrigerants like ammonia, which is 0. The global warming potential for CO2 is 1. They use 1 because it's in our atmosphere. We breathe it. It's around us, okay? So the easiest way I have found to explain this is where do they grab these numbers? When I first started learning this, what does that mean that 404A is 3,922 global warming potential? What does that even mean to me as a technician or a contractor? Well, what it means is, again, the starting point is CO2, and that's the number 1. So really what it's saying is it's a ratio. So it takes 3,922 pounds of CO2 to equal 1 pound of 404A. And that's the best way I can explain that. This chart is not to scale. It's very qualitative. If it was to scale, this 404A would be way off the screen here, okay? So I'm going to quickly walk through this here. Again, you've got your capacities or your pressures over here. You've got 134A like to the right. This line here below is the low temperature or low pressures. Between these two lines is your medium pressure. It's like 404A or 407 or 22. And then above this line, we have our high pressures like 410A. CO2 would also be in this if it was subcritical. The CO2 that you see above this point is what we would call transcritical, and we'll talk about that another day. So here's what we're using. Here's what's already in manufacture and also being sold. Here's where we'd like to be one day in a perfect world, the lowest global warming potential. And you're going to see a lot of this right here in the near future. R32, for example, that's a Daikin product, okay? You're already seeing it in PTEC units. You see it in window units. And it's actually half of 410A if you didn't know that. When we take the other half of 410A, the R125, that's actually only in there because it's a fire deterrent. R32 was used in Asia from the very beginning. They never did adopt 410A. It was right to R32. The difference being, again, is we add that R125, you can see the global warming potential rises quite a bit. If we strip it down to its purest form, the R32, it then becomes mildly flammable, but it brings back down the global warming potential significantly, okay? And let's take this example here. I try to take the fear factor out of these refrigerants when I'm teaching younger students because it all looks foreign to them, obviously. They only have an 8-hour window to see this stuff that we teach a lot of times. So the other thing I point out is 1234YF, if you know anything about automobiles, and even if you don't, this is a refrigerant we've been using for quite a few years now, 5, 6, 7 years. It replaced 134A. 1234YF, you're going to see a lot in the new refrigerants coming down the line. It's going to be a part of many, many blends down the line is what I'm seeing and what I'm hearing already, okay? So moving forward here, again, this is just a different way to look at that chart. Here's what we have in production, what we're using already. Again, you have your capacities and your pressures right here. Here's where we're moving into. A lot of technicians are already either using or have heard of R40, R449A or R448A. One of them is, they're almost identical. One of them is owned by Chemours. The other one is owned by Honeywell. And I can't remember exactly which one it is, but one of them has like a fourth blend where the other one does not. But they are so identical, pretty much cut and dry. Here's another one that's coming out quite soon, already out. We don't hear a lot about it just yet, but the testing's been done. This is a great replacement for 134A. It's called 513A. In fact, recently I suggested we changed our refrigerant over in our small simulators just in case we were to travel over the state line in California, where a lot of these things, the SNAP 20 and 21 and the CARB things are already going into effect. They're ahead of the U.S. as a whole. So we decided, the engineers did some testing, and they came up with the least path of resistance for changing the least amount of components on our small trainers would be R513A, okay? So very, very similar to that. And then we have our mildly flammable, the new kid on the block, if you will, the A2Ls. I added one refrigerant in here along with this, and this is 454B. For those of you that stay on top of this, I have probably 5, maybe 6 trade magazines that come to my house a month, and I've had those come here for quite some time. A carrier announced, I don't know, 6 months ago maybe now, that their replacement in 2023 for 410A is going to be 454B. That's made by Chemours. The lab number would be X41, okay? Again, they announced it. Carrier also was the one that announced, if you remember, that new refrigerant years and years ago called Puron that was R410A. They were the one that announced that years ago, and everyone soon followed. There have been some big companies like Trane, for example, and some of those that have decided they're going to go with 454B. I don't know all of them off the top of my head, but stay tuned with that. Be prepared for that. That is going into effect 2023, and that is your residential and light commercial. Okay, I just put that in there because it's something recently that's been talked about, but I don't see a lot of it being out in the public. And when I teach contractors, it seems like not a lot of people, if anybody, even knows about it. And then you have your different refrigerants here, your CO2, your 290, which is propane. The difference in this propane, by the way, than the propane used for your grill, it's going to be without a stench, with no smell, in other words, okay? So that's brought some concern up because it has the same flammability, but when we walk into a mechanical room, a technician might not know it's around them. So what's that going to look like in the future for us? Will we have to have maybe some kind of alarm strapped around our knee? And the reason I say knee is versus air, it's a 1.52 in weight, identically to CO2, by the way. So it's going to drop to the ground, the gases are, okay? So your detectors inside the mechanical room are probably going to be somewhere around 18 inches off the ground. And you may, I foresee possibly as fast as 290 is growing and getting traction in the industry, you may have to wear maybe some kind of alarm system with a Velcro strap that you strap on before you enter the mechanical room. I'm not sure yet. We still have a lot to learn about this refrigerant here, so stay tuned on that. And then you have ammonia, which is, as you can tell, the first letter is the toxicity. It is toxic. It is mildly flammable. The A stands for non-toxic or low toxic. I want to point out to you, even though this says no or low toxicity, anything with enough parts per million can asphyxiate you, even CO2, okay? At 15,000 parts per million of CO2 in a closed self-contained area, you're going to need some type of ventilation. If it hits 15,000, you're going to be gone. You're going to have some kind of alarm. And as it grows up there before 15,000, there's different things that are going to take effect, like dizziness and other things, okay? So just a quick snapshot of what that looks like with some refrigerants coming down. Lots of efforts are increasing around flammable refrigerants, as I just talked about, A3s and A2Ls. The HRI, Flammable Refrigerants Research Subcommittee, they're identifying gaps in flammable refrigerant research and developing a roadmap to complete critical research for a safe use. What does that look like? As a licensed journeyman, I can only imagine the building departments have to be brought up to par, because what you and I know on the front lines, they have to know now. Our fire departments have to know. So we really we don't want to get the carriage before the horse right now. I think Washington State, and I think Brian's on the call, on the panel today, but Washington State recently, about a month or so ago, I think they've already implemented A2Ls, I believe, into their building departments. So and what about warning labels? You know, we have to have warning labels. What's that going to look like? You know, so when someone is inspecting something, or again, if God forbid a fire breaks out, we need to identify those things in the building. So on that note, here are a couple new labs that we have in Sydney, Ohio, that Emerson is using. We're investing in the significant A3s and A2Ls testing capability. I toured this building last summer, I believe I brought my supervisor, Ben Weiser, and another instructor with me. We had to get permission to get in here. Obviously, it's not well-traveled. You have to get permission to come in there. But a lot of life test stands, a lot of good stuff going on over there. They're testing inside these chambers. These chambers can range from 0 degrees to a minus 120. So it's really high-tech stuff, and all UL testing, by the way, UL labs, I mean. certified, so very good stuff. 410A, it has been the U.S. industry choice for air conditioning for new equipment for quite a few years. Even though it's a blend, it has very little glide. It has glide, but we don't talk about it. Again, remember, there's two components, R32 and R125A. And the reason we don't talk about it, the glide in 410A is less than a half a degree. It's so small we don't just discuss it. We don't really even know it's there, to be honest with you. It's proven performance and reliability. It has no ozone depletion. And by the way, the ozone's almost completely, in certain areas of our atmosphere, is almost completely closed, which is a good thing. It has minimal fractional glide, as I just spoke about. It's got POE oil, which accepts a lot of things. It's good. Not a retrofit for 407C. The Emerson approved retrofit refrigerant for AC is also used in some new systems. And I changed these just recently. This used to say 452B. We now know that a lot of this is going to be, or some of it, a good part of it, is going to be 454B. And again, it's also known as XL41, a near drop-in for 410A. And then we've got R32 over there. Again, that is a Daikin product. Daikin, from what I understand from talking to Daikin people and the people that carry Daikin products around the nation, it sounds like for sure they're going to keep that R32 in their mini splits, for sure. I'm not sure about their unit systems yet, or their split systems and residential like commercial. That's still up in the air. I don't think they know for sure. Like I said, it's approved in the U.S. for PTEC units already. It is in window units and PTEC units, currently used in Asia significantly. And again, it's a pure fluid that have less expensive refrigerant cost, okay? By the way, a CO2, I didn't mention this. CO2, for example, the cost of it is somewhere between, from the West Coast to the East Coast, I have found it's somewhere between 50 cents a pound to the high end would be $2 a pound, okay? So it's very, very cost effective in that area. And it's not just about going green with CO2, by the way. I mentioned this the other day. Compression ratio, for example, for air conditioning is 3-to-1. Medium temperature is 5-to-1. Low temperature is 10-to-1. Now, the farther those numbers get apart, the harder that compressor is working, the more energy it's using. The compressors are more robust. So in low temperature, if we look at HFC as 10-to-1, on CO2, it's a 2-to-1. So the pistons are very, very small, and I'll try to show them to you the next time I present of how small they are. I've got a nice picture I took the other day of a piston that's about 1.5 inches, 2 inches across on a very large CO2 compressor. So Emerson is not promoting any particular refrigerant. I need to point that out for you for AC applications, okay? We don't own any refrigerants. We're just passing along knowledge right now as we know it. And refrigerants, as you know, with the way the things are right now with the EPA and those kind of things change rapidly. So stay tuned on that. So let's look at some retrofit refrigerants. Why retro refrigerants? Energy facilitates compliance with environmental regulations, the potential to upgrade to compressor technologies, increased efficiencies. So you have the DOE involved. You also, as we talked earlier, have the EPA, the environment, enables accelerated transition away from ozone depletion refrigerants, provides the opportunity to promote environmental leadership. And then we have the OEM or the equipment manufacturer. He has to know what these two are doing before he can start manufacturing, because if we start changing these things, the energy and the environment, maybe these evaporator coils are going to get a lot larger, so that equipment, the design is going to change, but that provides potential for improved compression reliability and lifespan. So, and then we have the economics of it, avoids costly equipment replacement, improve the life cycle cost of equipment. So you have Joe homeowner or Joe building owner, Mr. and Mrs. Jones, they're in the middle of this and they don't know what's going to, should they replace today or should they wait? So you have all four of these things connected together, okay? But it really all starts right down here. I don't want to give one favor more than the other, but between the EPA and the DOE, they have to work in conjunction with each other to know what they're doing, hopefully, so then the equipment designer can then make the equipment, and then the building operator or the end user knows whether to replace or repair or what that looks like in the future coming down the pipe. This is just showing you the OPI. It is our online product information. It is free for everyone to use. You can find information. It's going to show you guidelines on here for all your refrigerants. You can also find that on the AE app, okay? The AE app is free to download in your app store. You can go through and push, it has a little tank of gas at the bottom of it. You can push on that, and the first thing that'll pop up at the very top is the 93-11, and that's another way to get to this information, quite easy, okay, on your phone. The kind of information you'll find out here is your refrigerant and oil combinations, your compressor capacities, your distributor nozzle sizing, and expansion valve sizing, et cetera, et cetera. I just put a handful of things down there this morning just to kind of show you the kind of information. Again, it's free to you. It's called OPI, Online Product Information. I think tomorrow Brian Bisonek is going to actually be talking about this, so stay tuned for that. That'll be good stuff tomorrow. Considerations prior to retrofitting. Are the current compressors and system components compatible with the new refrigerants and oils? Will additional cooling be required? Will the system require flush to remove excess amounts of mineral oils when converting to POE oil? And when I say flush, I don't mean like RX11 or a flush. Emerson frowns on flushes outside. It doesn't mean it's a bad product. It has not been tested to where they're more than welcome to test it in our facilities or their facilities. We just have to see the documentation, and right now nothing's been approved. We like refrigerant, we like oil, and we don't mind nitrogen in the lines, but so I want to be clarified on that on the flushes, okay? Are the compressor capacities with the new refrigerant similar to the existing refrigerants? That's a good one. And will the sizing of the thermal expansion valves need to be addressed, or will the valves need to be adjusted to maintain proper superheat? Remember, many of the new refrigerants are blends and may have a glide up to 8 degrees. And we're going to talk about glide a little bit down the way here. Filter dryers will need to be changed and ensure that the dryer type and design are compatible with the new refrigerant oils. Pressure switches and controls should be verified and adjusted for the new refrigerant. So these are all things that we need to take in consideration when we're changing over to the new refrigerants. A lot of people use the phrase drop-in refrigerants. I don't know if I really like drop-in refrigerant, the term. That always is kind of misleading. I know when I was in the field, when I first heard the term drop-in refrigerant, it seems like you can just take the new refrigerant and drop it in. That's not necessarily what it's saying. It's saying maybe that it's more like the like, but what in the pressure temperature more so that's going to do. But you still might have to have components changed out, okay? Be very aware of that. Is there an opportunity to upgrade system performance, digital or modulated compressors, floating head pressures down, reduce number of compressors on the rack? So these are other things to be taken into consideration when you consider the changeover also. And then how will you manage the system downtime? Are we going to be working around like food product, meat? How are we going to manage that downtime? What's that going to look like? You know, are we going to take that in consideration so we don't lose any product or any spoilage? 8 easy steps for refrigerant retrofits. And again, you can find these in the AE Bulletins. Again, if you download the app. Always follow recommended safety guidelines and procedures. Establish a performance baseline with the existing refrigerant system. We have to know where we were at, so when we get to where we want to be, we have something to compare it to, right? Leak check and repair all leaks prior to changing refrigerants. I think that's kind of a no-brainer. I would repair everything that you know is possibly leaking before you put that new refrigerant in. In other words, while you're using the old refrigerant, it's a good time to look for those leaks and repair them when you're making that changeover. Remove mineral oil from the compressors if applicable. Recharge with the appropriate oil. Will the system require a flush to remove residual oils? Again, on our 9311, you'll see all the refrigerants and oils and what they're compatible. It'll show you, it'll actually point out to you, all of our compressors, for the most part, are going to come with POE oil, and they will, what's the word I'm looking for? They will match up with the mineral oil as long as it's not too much, and we'll talk a little bit more about that. I don't know if I'll touch on it today. Hopefully, I might get to it here in a little bit. Remove existing refrigerants. Weigh the refrigerant recovered from the system. Change filter dryers and other components as required, and then verify pressure settings on the controls. Safeties. Evacuate system down to 250 microns. Verify system is leak-free. And not necessarily has to be 250 microns. I know a lot of guys and gals are going down a lot lower than we used to. Emerson wants at least 500 microns or less. I know from traveling around the nation in the last few years, I see more and more they're going down to 300, 200. It's amazing. There used to be we used to believe that if we went down too low in microns, that the oil would break down. That's just not true anymore with the POE, so don't be concerned about that. In fact, I think Appion, some of their products will pull down to 50 microns. Now, do you need to be down that far? I don't know. I guess each one has to be handled differently. 7, charge system with new refrigerant into the high side of the system to about 80% of volume of the refrigerant initially removed. Remember that with blend refrigerants, we can only charge in the liquid state. I want to point out to you that we want to weigh that in, obviously, okay? Weigh in and weigh out. Always get in the habit of weighing in and weighing out. And then start the system and adjust charge. Verify your superheat settings. Optimize system operation. Label system with the new refrigerants and oil combinations. I would also point out if it's a TXV application, which most are anymore, you want to make sure your subcooling's dialed in. In order to get correct superheat, we got to make sure our subcooling's correct, right? Through this in we talked about the other day, I know, but I wanted to point this out because I wanted to set the workup we're going to do for Glide. So I want you to think about this 212 here. This is a graph using water as our example, okay? And what it's saying is this is at atmospheric pressure, which we know is at 14.7, okay, standard atmospheric pressure. In Denver, it's going to be different, obviously. But what it's saying is your BTUs equals the amount of heat energy to raise 1 pound of water, 1 degree Fahrenheit at sea level, okay? So at the 32-degree mark, we've come out where there's no ice. There would be an ice and water here at 32 degrees, okay? And that would be latent, okay? Now all the ice is gone, so the water starts to warm up. We get to 212, we're boiling. So this is our boiling point for water, okay? So this is where Glide will take place on normal refrigerants with several components or multiple components, okay? Different refrigerants, okay? We get to that 212, all the liquid's gone. We hit 213, that's going to be 1 degree superheat or 1 degree sensible. Life is good. This is our business that we do every day. That's the evaporator. On the way back from the vapor to the liquid, that's our condenser, okay? And we just talk about the energy here, okay, of what we're doing. But I wanted to show this 212 here with this straight line before I go into Glide. So Glide occurs when different components in a refrigerant blend evaporate at different temperatures within the constant pressure of evaporator. Now we have 2 different types of Glide, okay? Single component or azeotropic blends. Azeotropic blends are refrigerants with 2 components or more that have the same boiling, are very close to the same boiling point. We could say 410A is the same, okay, an azeotropic. A non-azeotropic blend is something that has different boiling points. So you remember back in the day when we started going with blends, we started to see our evaporator coils get larger and larger and larger. Well, when we have this boiling point that's pretty consistent, like that 212 with water, this azeotropic, it's got the same boiling point at a certain pressure. But when you add blends, you're going to have different boiling points. So this is what we call Glide. So one refrigerant starts to boil at this temperature, let's say 212. The next one might boil at 214, 216, 220. Well, and I'm just throwing numbers out there to give you an idea what that looks like. But this glide is going to be a lot longer boiling point. So therefore, our evaporators got larger, didn't they? They got larger because they're boiling off at different temperatures, right? So that's what glide looks like to you and I. Now, when we start at the glide here, at the liquid side, the beginning of it, we call that the bubble point. And then the back side of it, when we go into vapor, that's called the dew point. We use those on our PT charts. Some people use midpoint, which I think Honeywell does, and that would be somewhere in between them. But if you look at a PT chart and it says bubble point, you're using bub for your subcooling, or bub sub. Remember, bub sub, okay? Dew point is dew for superheat, okay? So we use dew for superheat and bub for sub, all right? This is a vapor. This is our liquid, condenser, evaporator, okay? So remember that. Coil temperature for the refrigerants with glides must be handled differently when determining the refrigerant impact on the evaporator. Again, what's that going to look like? If we have different boiling temperatures, we're going to have to take that in consideration with our evaporators. The manufacturers will. So here's an example of some temperature glide for 404A replacements. 404A, this little squiggly mark means nominal or close to, by the way. 404A is 1 degree, so that's pretty close in glide, right? But then you look at 407, we have 8 degrees of glide. So it starts out with that glide just like we looked at, okay? And it's significant considerations needed for temperature glide, system, component sizing, and et cetera. And then we have 448A, the one we talked about that's working its way in the industry right now. That's a 7-degree glide, okay? And then we have 134A, which is 0. It's a single component. And then 450A, near azeotropic, right around 1 degree, and also 410A. Temperature glide is significant for A1 refrigerants. A1, again, a non-toxic, non-flammable, 404A. Replacements, not so much for 134A. Sorry about that. Going live in my kitchen and the UPS man knocked on the door. Sorry about that. Okay, I threw this in real quick because I like helping people out when we're along the road. It's not really on topic, but I want to show you real quick what that bub and sub looks like. I tried to show this the other day and I found out it didn't come up because of the graphics or the animation wasn't showing this. So this is our enthalpy chart, okay? We've got our liquid, we've got our vapor over here, okay, our liquid. If you ever get into a situation, I know we're all just contractors and technicians, but I always think it helps if you want to, better yourself or get a raise, to understand as much as we can. So in a very simplistic form here, I want to point out to you what this means to you, the 4 sides of the square of this inside this enthalpy chart, okay, this thumbnail, if you will. First of all, between these 2 lines of the dome, that's our 2-phase area, okay? Outside the dome, again, this is liquid and this is vapor, okay? Everything inside here. So is in a real simple form here, what this line is telling you, the pictures are actually here for you on this one. I picked this out specifically, but a lot of times they're not. This is what the compressor's doing, okay? This line is telling you what the compressor's doing, whether it's by the pressures over here or the temperatures, all right? So it's showing you. When it comes across here in this area, that's significant. That's showing you the condenser, okay? And this says condenser, that's why I chose it. But if you ever get into a situation where you're working around engineers or designers or your service manager and you want to be in that conversation, that's what this is telling you. It's just saying what the condenser. We're rejecting the heat here. Notice we're in that 2-phase area, okay? All right, we're going from our liquid to our vapor to a liquid, pardon me. And then we get down here to number 3 and we start to go vertically down. That's signifying our TXV, or our metering device. When we get down here into 4 and we go across, we're absorbing our heat here. We're also in that 2-phase area. We have liquid and vapor. That's our evaporator, okay? That's latent right there, latent heat. We're absorbing that heat, changing state without changing temperature, right? Okay, enough of that. Let's talk about lubricants. Lubricant screening criteria. Lubricity. Lubricity. We need lubricity in our compressors, don't we? It's the ability of oil to minimize friction between the load-bearing parts, for example. In a piston-type compressor, the thinnest film of the inside that compressor is inside the cylinder wall and the piston itself. Okay, so we need the good lubricity in there. Lubricity is very, very important for everything we do with compressors and our components. Okay, we have to get that oil around. We want our refrigerant lines to have at least a ½ inch fall in every 10 linear feet. We need to trap properly. Okay, we have to have everything going for it. The reason we size our refrigerant lines, by the way, if you don't know that, the two biggest reasons is for volume and velocity. It has to be large enough to bring volume back to the compressor to cool it, and it has to be small enough to bring the velocity to push that oil back to the compressor and to the components to lubricate it. Miscibility. It's the ability to refrigerant to mix with oil, okay, the miscibility. And hygroscopicity, pardon me, that hard to pronounce there. Ability of oil to absorb moisture, like the POE oil, okay? POE oil that's actually removed, the moisture is removed from it. That's why you see POE oil, by the way, in metal containers. When POE oil first came out, it was in plastic containers, and when they were new to the POE oil. When it was sitting in the warehouse of the distributor, what they found out is when they went to go sell it and people were putting it in their systems, they had moisture problems. And what they found out was that POE wants to go back to its natural form, and it absorbed the moisture right through the plastic containers. So that's why today you see when you buy POE oil, it's in a metal container. That's the purpose for that. And material compatibility. Is it going to eat the compressor up? Is it going to eat the components, the motor, the compressor? It has to be compatible with that, okay? Lubricant choices. We have mineral oils. Do not work well with HFCs. Lack of miscibility. Less lubricity without chlorine molecules. And then we have alkylbenzene mineral oil mixture. Can be used with retrofit HCFC mixtures. And then we have polyester oil, suitable for all refrigerants, okay, except I believe R12, if I'm not mistaken. If you want to know more about that, you pull that AE app. Again, you can download it for free. AE Bulletin 1320, oil management for scroll compressors, a lot of good information there. Backward compatible with mineral oil. That's what I was trying to say earlier when we talked about flushes, by the way, and it was slipping my mind. Backward compatible with mineral oil. All of our compressors, or most all of ours, some come with PAG overseas, but POE oil and a little bit of mineral oil is not going to hurt on installation, okay? Required for HFC refrigerants. POE characteristics. Polyester differ from mineral oils in 4 basic ways. They're hygroscopic. They're polar. They're very, very cleaning agent. So if you're not brazing with nitrogen and you're getting some of those particles in there, inside that, POE oil is going to come through there with the refrigerant, and it is going to act like a cleaning agent. It's as good as RX11, if not better. So everything that's in there is going to flush out and probably get caught in your TXV or your liquid line filter dryer, depending on where you braze that line at, okay? And possesses unique additives. And it will hydrolyze or create acid in the presence of water. We call that copper plating. When we don't get all the moisture out of something, we don't pull down to the proper microns, 500 or less. We get that moisture in there, and then it gets hotter and hotter. And with heat and moisture, it becomes acidic. That moisture becomes acidic, and it starts eating away all the copper, everything it comes in contact with, all the lines. And when we tear compressors down, we see this very often, and we see copper plating. So everything it comes in contact with, the valve plates, the pistons, it then turns to copper. It looks like a shiny penny. And the more moisture that was in there, the longer it ran, the shinier and more copper looking it becomes. So POE handling practices, again, in a metal container. Hygroscopic characteristics of polyester requires new procedures. Metal container to prevent moisture absorption are required. tight seal on less than full containers. Just my recommendations. I don't recommend buy what you need in POE oil. Don't buy more than you need and then try to seal it. It's a very risky. Okay, I've seen a lot of people do this. I like to buy POE oil in the smallest amounts I can and use it as needed. Trying to save it for long periods of time, you're just taking a chance of adding moisture to it. So be very careful with that. Moisture is a killer on a lot of things we do in the refrigeration systems, right? 100 parts per million moisture content in the systems, that's the standard. I think all of our sight glasses typically go off at 75 parts per million, 100 parts per million moisture content on systems. We're going to get copper plating, as we talked about, corrosion wear, reduced compressor life, okay? We test all of our compressors, by the way, to last at least 15 years, as long as they're inside the envelope. Inside the envelope, meaning that you're doing your regular preventive maintenance, okay? You're not outside that envelope. You're not running high head pressure. You're not running low suction pressure. The evaporator coil's clean, low suction pressure. The condenser coil's clean, high head pressure, okay? So that we want to keep it inside the envelope. If you keep it inside the envelope and maintain the system, you should easily get 15 years life out of all of our compressors, if not longer, okay? So we test all the compressors to last at least 15 years, okay? ZR compressors with POE oil. This is just a nice little bulletin pointing out what I told you earlier. The POE oils we recommend are backward compatible with mineral oil. This allows a compressor containing POE oil to be installed in a system that contains mineral oil. The two oils, because of they are fully compatible, can be blended together in any ratio in R22 application, for example, okay? This is that 9311. Again, you'll find this in our AE bulletins. It's referred to as our 9311. And what it's telling you, this bulletin is telling you, these are the refrigerants. This is what they're similar to, R12 here, 502, 404A, and over here are the refrigerants that can replace those or that are similar to. This isn't a pay-to-play bulletin. Basically what it is Emerson sets the bar so high, we have to keep it inside the envelope. These folks and their products test their products. If it stays inside the envelope, per se, it makes this 93-11, okay? This shows what type of, if it's in a retrofit, low or medium temperature. This is in new equipment. This is the preferred oils. This is the alternative oils, okay, and alternative twos. These are the applications that we have approved them in, okay? You want to constantly check for updates. If you use the AE bulletins as opposed to a book or a card, you'll constantly get updated and you'll have the latest information, okay? On the back side of it, basically this is just showing all the flushes and any kind of dyes that we approve of. And to cut to the chase, we approve very little. There is this one dye, I'm not familiar with it. It's called Spectronics Arglow. And again, the only reason it's approved is they spent their millions of dollars to do the testing to prove to us that in our application in the right amounts, that's key, right amounts, it will work and stay and be compatible with our compressors and stay inside the envelope, okay? It doesn't mean any of the other products out there are bad. It just means they haven't been tested. They haven't spent their money to test it in our applications, okay? Again, AE Bulletins, use the AE Bulletin mobile app. This is just an exercise I normally do in class. It's not going to work, obviously, here live on the WebEx. But again, these are some of the things you can look up. Here's that tank of gas I was telling you about on the AE Bulletins. Once you hit that, you can touch on all these. Okay, this section is kind of like Google, if you will, for Copeland products. This tank of gas will tell you all about refrigerants. The very top one is that 9311 I just showed you with lubricants and refrigerants that are approved for Copeland compressors. Below here is guidelines for refrigerant conversions. Again, this is a free app. Spend a lot of money on these apps. It's not cheap to make these apps. Please utilize them. I know if I was still in the field, I would. They make life a lot easier. It takes all the math work out for you, a lot of phone calls. You've got it's like a little guardian angel on your shoulder, if you would. Really, really, really use these apps, okay? Other additives and agents, again, Copeland does not approve of the use of leak stop compounds, acid neutralizers, cleanups, other oil additives, flushing agents in proper use, leak dyes, Spectronics only, must follow instructions. What they're saying there is if it says, you know, a quarter of an ounce or per so many pounds of refrigerant, you have to do it that way, okay? If you don't, you're going to throw that refrigerant off, that saturated refrigerant in there. It won't be the same. You know, if we check something saturation with the refrigerant or vapor and liquid, we can go to our PT chart and we can look at what that should be at a certain temperature and pressure. But if we throw a bunch of chemicals in there, that's going to throw that off. For example, Spectronics leak dye, the one we approve, maximum 0.25 ounces per gallon for chillers and supermarket racks. We have a maximum of ½ ounce per gallon for residential and commercial AC systems, specific for the type of lubricant, okay? This is too much, okay? This was at an actual teardown that we did, okay? And you'd be surprised how many times Dustin can tell you that we tear down compressors, and all my other co-workers, other instructors will tell you that you would be surprised how many times, you know, they're not all this bad, but how much times. I actually take a little light out that you use for tracing dye leaks, and I stick it in the compressors and show students time and time again. It's on the average, if we have 10 compressors we're tearing down in Denver, Colorado, or San Antonio, Texas, 7 of those will probably have dye in them at some level. Small trace to something like this. I've seen this more times than I can count. It's amazing how much. And when you put this in here, do you think that's running inside the envelope? Have we thrown that chemical, that refrigerant off, that blend? We sure have, okay? Our PT charts probably wouldn't even work with this inside the systems, okay? Always read manufacturer's instructions. And I believe that is the end for me. And here is my email again, don.gillis@emerson.com. Okay. And Kara, I'm not sure if there's any questions or not. Hopefully you all enjoyed it.
Thank you, Don. We would now like to take some time to answer some questions from the audience. Please utilize the Q&A chat box in the corner of your screen. Don, the first question that we have is, do you see some of these types of applications going into other areas other than supermarket applications, such as home and light commercial applications?
CO2, yes. If I heard you right, CO2, yes, for sure. And the reason I say that is Andre Patinod is an expert globally in CO2, I think I can safely say, for Emerson, and was one of my many mentors, the mentor at the beginning. And he has shared with me a couple times that they already have CO2 systems in residential applications in Japan. So yes, I foresee once the technology's there, I see a lot of these natural refrigerants, like it or not. Again, I don't get into politics. They are very efficient. Propane's very efficient. So yes, I do. The easy answer is yes.
Another question that we have is there a big pressure difference between 410A and its future replacement?
No, there is not. It is fairly close, very like to like at 454B, if I'm not mistaken. I reached out to Chemours when it first came out, and according to their trainer over in Indianapolis, Jamie Haley, I think his last name is, he mentioned that the pressures are almost identical. It is very, very close. So, and the global warming potential it's less than R32, so it's way down there. It was that's what kind of caught us off guard. I think we were thinking it was going to be 452B, I believe, and R32, and out of the blue they came up with 454B. So they're pretty much like. Another little known fact too is it's kind of a little bit off topic, but not so. R290, for example, propane refrigerant, again, which is starting to be used a lot, and it has a 150 gram limit right now, but that's possibly could be bumped up in the near future. That PT chart on R290 is almost identical to R22. I mean, it is about as like for like as you can get. So there's some to try to bring that fear factor down a little bit in some of these new refrigerants we're coming out with. Kara, thank you.
Another question that we have is, if too much dye was used, how do we flush out the pipes and the rest of the system after draining the oil inside the compressor?
We want to use nitrogen. We're big fans of nitrogen, okay? We don't like any flushes. We have to keep, once we get the system back in, unfortunately, a lot of this stuff, it's once you get that much in the system, like anything else that gets in there contaminated, you're going to have to use a suction dryer. You're going to have to put the suction dryer in there. You're going to have to run it for anywhere from 48 to 72 hours. You don't want to leave it in. Okay, you're going to, on a commercial, you're going to use like a block type filter. In a residential, you're going to just use your typical suction dryer. You're not going to leave either one of those in, though. Again, we don't want a pressure drop in that suction line or capacity. It kills the capacity. After you use the suction dryer, you need to go back and acid test the refrigerant again and make sure that it's cleaned up. If it's not, you have to repeat that procedure until it's all the way cleaned back up. So that's going to be, and that kind of stuff, by the way, is exactly what's in that AE bulletins that I showed you earlier. When you change from one refrigerant to the other, it literally goes step by step and tells you all those procedures. Very, very good stuff. Thank you.
Another question that we have is, do you see these types of applications? Ooh, whoops. It moved on me. Do you see the industry going to POE oils in the future as Mitsubishi has done with their equipment?
What was the first part of that? I apologize.
Do you see the industry going to POE oils in the future as Mitsubishi has done in their equipment?
You know, that's a good question. Is Brian still on? Brian might be able to answer that. I have not heard that, but I've installed a lot of Mitsubishi back in the day on mini splits. Brian, are you still on by chance?
Yeah. Can you hear me?
Yeah, I can.
Polyvinyl ether is another synthetic oil, and it is an alternative to POE oil. It's actually even more hygroscopic than POE oil. So, it is being used, I know, in some of those types of applications, air conditioning applications, but I don't know if it's going to become widely accepted.
Very good. Thanks, Brian.
Another question that we have is, with regards to anti-leak compounds, I have heard that Nylog from Refrigeration Technologies is made from oil and shouldn't compromise a system. Is this incorrect information?
Well, that's a slippery slope for me, and I'm going to be brutally honest with you here, because this is very hard for me sometimes as a technician. When I know something, that I've used something, I don't want to come off like a hypocrite. So I have a lot of peers, they're nationally speakers like ourselves that do this and are ex-technicians. So the first thing I want to say is I think Nylog is a very good product, okay? Back in the day when mini splits were first being installed, a lot of problems were happening with the flare fittings. It was very, very hard to keep the charge. I know I went back on 15 units one time on an apartment complex, and I know I did a good job of pulling them down, and they were all almost flat. We had to start using some type of oil when you connect brass on brass. So Nylog, what Nylog is, for those of you that are listening, it's basically just a lubricant that you put on the threads. It's not a Loctite, it doesn't lock it, but it puts a nice seal on that. However, when it comes to Emerson, again, we don't want anything mixing inside the system, but that particular product is outside the system, in my beliefs. Brian might have something to chime in on that. I know back in the day, I know Fujitsu frowned on it. I gave a lot of Fujitsu technical classes back in the day when I was on the other side. But as far as that Nylog product, gosh, it's a very, I've seen some amazing things done, and it is not snake oil, but it's not on our list. It's not on our 93-11, but NILOG technically isn't inside the system. It's on the outside as far as I've ever used it, unless you know something I don't. That's how I would address that, okay?
Another question that we have is, what is the main difference between azeotropic refrigerant and non-azeotropic refrigerant other than temperature glide?
The difference in it?
Yes.
Is that what you said, Kara? The difference between the
yep.
two?
The main difference, yep.
The main difference in my opinion is, and I want Brian to chime in on this too, is I personally think it's just your glide. One of them is either a single component or something with two refrigerants that have very minimal glide, such as 410A, and the other one is one that has a lot larger glide. Am I correct on that, Brian?
Yes, Don, you're correct.
Okay, thank you.
Another question we have is, how do you know when to use POE 32 versus POE 68 oil?
That's a good one. So that is going to be by design. The designer is going to make that call. You have to look that up on your bulletins. I know that one has to be by application. That would just be by system. I don't know if there's any magical way to but it would have to be. You're gonna see that in the specs for either the refrigerants or the application. Again, that's the only way I know of. It would change from each application depending on what you're doing. I know CO2 is different than HFCs and those kind of things. Brian, do you have anything to add on that?
You can refer to a Copeland document 93-11, which does list some different, refrigerant alternatives by application, what's preferred and what alternatives are acceptable.
Yeah, very good.
93-11, if you just Google that for Emerson, you'll find it, or you can find it in our online product information.
Yeah, perfect. Yeah, good, yes.
Another question that we have is, I was told if R22 machine needs more refrigerant, if R22 is not available, just add some R407. Is that true?
That is false. We're never mixing any blends. Again, that's going to change that system, that compound of that refrigerant. And we never mix refrigerants, never ever mix refrigerants, purposely mix refrigerants, okay? You cannot add anything to any refrigerants as far as I know. I know that, again, that's the reason I don't like, when they first came out with replacement refrigerants, I like to use the word replacement rather than drop-in. I think drop-in was misleading to some technicians out in the field years ago, where they got this feeling that they could just drop it in. Just the example that question was driven at. You never want to mix refrigerants. Now, are they the same as far as pressures and temperatures? Possibly could be, but that doesn't mean you never want to mix a refrigerant. You always want to keep it in its purest form, because if you don't, but how can you check anything? How can you check your subcooling or your superheat? It wouldn't be correct because you're throwing that off. Okay?
And that is all the questions that we have for today. Thank you, Don.
Thank you.
And thank you, Brian, for also chiming in and answering some of our questions.
Yeah, thanks a lot, Brian.
As a reminder, a recording of today's presentation will be available to you on our contractor resources and HVACR training pages on our website at climate.emerson.com in a few days. In addition, we will be providing you with a certificate of course completion following the event via email in a few days. Thank you for joining us for today's presentation. We hope you can join us tomorrow for contractor resources available from Emerson.